All right, so I think this is recording. Let's take a look at these three problems. They are quadratic equations, but this time the directions are telling us to use the quadratic formula to solve these. So we need to rewrite each of these equations and get it in a standard form. Sometimes may call it a general form, but I usually call it a standard form. Oops, that is not 1. That is C. So x is equal to this fraction where the denominator is easy. It's 2 times a. There's 2 terms in the numerator, and the first term is easy as well. It's the opposite of b. And then you'll have plus or minus the square root of what they call the discriminant. And that discriminant is b squared minus 4ac. All right. So let's jump in and take a look at number 10. It is in standard form, so we can start out right away by identifying A, B, and C. So now by substitution, we take in the numerator the opposite of B. The opposite of positive 7 is negative 7, plus or minus. You know what, though? I'm going to find the discriminant first. We're going to see later that if I come in and find the discriminant first, it'll tell me what type of solutions that I'll expect. And I have to find it anyway. It's in the formula. I have to find that number that's underneath the radical. B squared is 49 minus 4 times 5 times 3. 4 times 5 is 20. 20 times 3 is 60. And so this is a negative value. And I know that when it comes to taking the square root within the set of real numbers, we have to take the square root of non-negative numbers, either 0 or positive. We can't take the square root of negative 1. So for this problem, there is no real solution. And that's a little bit of the advantage of finding the discriminant first, is that sometimes it can save you time and effort. Instead of doing the whole quadratic formula, you're just doing part of it and then immediately making a conclusion and moving on to the next problem. All right. Later on in skill packet 6, this equation does have solutions. It's just that they're not real number solutions. We look at the set of complex numbers. We define something that's called an imaginary unit, and that will provide us solutions to any polynomial. All right, so let's take a look at number 11. It's not in standard form. Let's get this in standard form. Let's add 1 to each side. So I have 2x squared minus 12x. When I add 1, 9 plus 1 is 10. I notice that all of these are even numbers. So to make the problem easier, to make the number smaller and more manageable, I'm going to divide every term by 2. 2 divided by 2 is 1. Negative 12 divided by 2, minus 6x, and half of 10 is 5, and half of 0 is 0. So now I'm able to identify A, B, and C. Let's find the discriminant first. It is that part of the quadratic formula that's underneath the radical. B squared means to take negative 6 times itself. That's going to be 36 minus 4. Well, A was 1, and C is 5. So 36 minus 20 is 16. Now, since 16 is a perfect square, that tells me that these two solutions that I'm going to have are both going to be rational numbers. And we could have solved this by factoring. It would, not every trinomial can be factored, but this one definitely could, because this is a perfect square. So let's tell people what our solution is then. The denominator is 2 times a, which 2 times 1 is just 2. The first term in the numerator is the opposite of b. The opposite of negative 6 is positive 6, plus or minus the square root of the discriminant, and the principal square root of 16 is 4. And so now I have that 6 minus 4 is 2, and 2 divided by 2 is 1. That 6 plus 4 is 10, and half of 10 is 5. So I have these two solutions. And like I say, because they're rational numbers, I know that at the beginning of this problem I could have factored it, but the directions didn't say to factor it. So all right, so let's move this out of my way. So if we look at this problem number 12 here, it's not in standard form. And with this negative x squared, I personally prefer to have the a, the leading coefficient, be a positive value. So when I write this in standard form, I'm going to move these terms to the right-hand side. So if I add x squared to both sides of this equation, I have 1x squared. If I subtract 6x from both sides of this equation, negative 1x minus 6x, I've got minus 7x, and then I have plus 9. So now this is in standard form. Let's identify a, b, and c. Let's come in and find the discriminant. It's the number that's underneath that radical. B squared, well, negative 7 times itself is going to give us 49, minus 4 times 1 times 9. 49 minus 36 is, I believe, 13. Since 13 is not a perfect square, I expect two irrational solutions for this problem. So let's return back to our formula here. Our denominator is pretty easy to determine. 2 times a when a is 1, 2 times 1 is 2. And the numerator is not too terrible. The first term is the opposite of b. The opposite of negative 7 is positive 7. And then we have plus or minus our square root of our discriminant, which we found to be 13. So there, we're done with this. That's our answer. We can't simplify that. If we could simplify it, then they expect us to do that. Sometimes it'll be the radical, sometimes it'll be the fraction itself that reduces. Sometimes both. Oh, okay, we're done. That was no. I was looking for another problem. All right, well, ask questions if you need to, and I hope that helps. I'll talk to you later. Bye.